Alright, hi everyone, this is Max Joseph, and today I'm going to be walking through some content on assertions and testing in Python. And I'm going to be working with a data set that is essentially just a couple of URLs that are associated with scientific publications. This is part of a project that we're actually undertaking at EarthLab to understand how people cite or don't cite data in publications. So what we're going to do is look at each one of these publications and see if we can extract out the papers that these publications cited. And we're going to hit the Crossref API to do that. So let's jump right in. First thing I'm going to do is open a Jupyter Notebook. The first thing I'm going to do is open a Jupyter Notebook and load the data. I'm going to use pandas to do this. This read CSV function will allow me to read this CSV file in as a data frame, and we can take a look at it. For instance, let's look at the shape. It's just got 9 rows and 1 column. Let's print that out. So the one column that's here is called publication URL, and there are 9 URLs, each of which corresponds to some scientific publication. In order to see if I can get reference data for these publications, I'm going to use a Python library called Habanero, which we can import. And Habanero is a Python package that hits the Crossref API. Crossref, if you're not familiar with it, is a service that allows you to extract metadata and data associated with scientific publications. So for some of these papers, we should be able to figure out what are the things that these papers cited. So I'll show you an example for one of them. The first thing we need to do is initialize a Crossref object. And so to do this, I'm going to use habanero.crossref. And this object on its own is not particularly useful, but we can use this to search for particular DOIs. So for example, if I want to search for data from one of these publications, I could take that URL and use this .works method, passing in the IDs argument. And let's see what this gives us. Essentially, the response from Crossref is this big hunk of JSON. So in Python, we can think of this as a dictionary, and so we can see that the response status from the API was okay, and then we get a bunch of data associated with this publication. So for instance, we can see the publisher, who funded it, the title, mercury exposure, and altered parental nesting behavior in a wild songbird, etc. What I really want to know for this publication is whether it has data associated with all of the papers that were cited in this publication. And looking through this JSON, I can see that actually no, we don't have a list of references for this. And let's dig into this a little more. Instead of just printing this, I'm going to save it into an object, and let's just dig into this object a little bit. I can see that it's a dictionary. Let's see, since it's a dictionary, it should have keys. Here are the keys: status, message type, message version, message. And I know from some previous work that if it has reference data, it should be in this message key. And this also is a dictionary, so it should have keys. And I'm printing out these keys. On its own, these keys are not super easy to parse, but if I sort them, I can look through them and see, okay, this does not have something called references. It does have the number of references, but I want to know exactly what papers were referenced. So for this first paper, I can see that Crossref cannot give us reference information. Let's do this again for another one of these publications. Now I'm going to take this second URL and do the same thing, replace this first URL, and see what we get. Alright, so again, this is a dictionary, has the same set of keys, and that should generally be the case. Now if I look through the keys contained in this message, I see now that we do have something called reference. So let's take a look at that and see what it contains. I'm going to print out response message, and then let's just pull out this reference key. And so you can see it's pretty much JSON all the way down, but we can see every single reference contained in this paper. So these are the things that this paper cited. And that's really the data that I want to work with. So to make this a little bit more concrete, I want to do this certainly for these 9 publications, but I may want to do this for other publications down the road. So let's see if we can bundle up this logic, the steps that we've been going through manually, into a function. And so the way I want to do that is I'm going to define some new function called has reference data, and the argument to this function should be a DOI. Okay, so I can just steal some of the code that we've been working with here. I know that I need to hit this Crossref API, and instead of hard coding a URL here, I'm going to paste in DOI. And instead of manually looking through the keys, we can do something a little bit more clever to see whether this message contains something called reference. Right? So in Python, you could also do this using something like this: reference in response message. In this case, that's true. And this is really what I want this function to tell us. I want it to return a Boolean, either true or false. True if this DOI has some reference data associated with it. So that's what we're going to return. Return reference in response message. There's our function. Let's try it out. So we know that the first publication URL should not have reference data, and we expect then that this would return false. Let's see if that's the case. So let's pass in, instead of copying and pasting, I'm going to just pull out the 0th item, the first item, using indexing, and I can see, yeah, we get false back for that. That's good. Let's try the second one. We should expect this to be true because we checked it manually. Okay, this function seems like it's working, at least for these 2 cases that we've checked already. Now let's use this function on the rest of our URLs. And to do this, I'm going to use a list comprehension. If you haven't seen this before, I'll give you a really quick overview. A list comprehension is kind of like a for loop, but it's all on one line. It's a little bit more compact. So what I can do is print out DOI for DOI in D, and then let's pull out publication URL. So this is a list comprehension, and essentially all it's going to do for me now is print out each of the DOIs in order. But what I really want to do here is pass the DOIs into my function instead of simply printing them out. And so I can do that as follows. Instead of printing DOI here, I can say has reference data and then pass in the DOI as an argument. So let's run this and see what happens. It might take a second because it does have to hit the Crossref API for every one of these. Uh-oh. So here it looks like we've got an error, and if we look through this traceback, it appears this is an HTTP error, and in particular it's a 404 error, which means that this URL was not found. And it turns out that this is the case with Crossref. There are some times where you look for a DOI and Crossref cannot return any information on it. So what can we do to deal with this? If errors happen from time to time, that could be a real problem, especially if I'm running this for thousands and thousands of URLs and I get occasional errors that break the entire program. One way around this is to use something called a try and accept. So I'm going to modify this function a little bit. I'm going to try to get a response from the Crossref API. And I know that that might return an error from time to time. If it does return an error, I want my function, instead of raising this error like it did down here, let's just say that I want my function to return none. Okay, so this is a try accept block. You try to do something. If that returns an error, you do something else. You handle that error. And if it doesn't return an error, then we'll just keep going to the normal return for this function. So let's update our function, make sure that these first two cases still work as expected. This should be false. This should be true. Great. And now we can use our list comprehension to apply our function to every single URL in this data frame. And you can see that the output is now a vector of trues, falses, and the occasional none. So this element inside this list corresponds to a DOI that Crossref would have returned a 404 error for. But instead of returning that error, now we're actually just returning none. Okay, so that's great, except this is a little bit clunky and not particularly robust, because if any error is raised inside of this try block, we will return none. So for example, if you leave to go get a cup of water and your cat walks across your keyboard, modifies your function in a way that it no longer makes sense, like this, and you don't notice, if I rerun this, I'm always going to get none, right? And that's essentially because this object, doiqfatees, does not exist, right? So if I didn't have this try and accept statement, what would happen? Well, I would hope that Python would tell me that this object is not defined, okay? And this is good behavior, right? If we're writing code that just doesn't make any sense whatsoever, we want to know that. We don't necessarily want to return none all the time. So we need to be a little more specific about the types of errors that we want to handle. So let's remind ourselves of the specific type of error that we get when Crossref can't return data. It's an HTTP error, okay? And in particular, it's a certain type of HTTP error. So if you dig into this traceback, you'll notice all the way down here, this is where the error is actually being raised. And if you look at what is raising the error, it's inside of the requests module, and it's in this models.py file. And it turns out that this HTTP error is a particular type of exception contained in the requests module, and this is the specific type of exception that we're running into. So let's modify our code so that we only return none when we get this specific exception. We can do this by importing requests, because this is where this error has actually been defined. And now let's add a slightly different try and accept block. Okay, so instead of just accept colon here, what I'm going to do is I'm going to be much more specific. So if we get a requests.exceptions HTTP error, and I'm going to explain what this as ERR thing is later. I want to print the error and then return none. So ERR, this is essentially going to be a name for the error that we get. We want to print this exception, but we're not actually going to erase the exception. So we'll be able to see if we would have encountered an error, but we're not going to halt the execution of our program if that happens. Okay, so now this is a little bit different. We still have everything under try is identical, but now we're using a specific type of exception under this accept block. Let's check the behavior of our function. We should still get false and true for these first two examples. And now, if we run this for all of our examples, let's see what we get. Okay, cool. So now we've got false, true, true, false, false, true, none, true, and false. And you can see that we've actually printed out the error, but we didn't raise the error. So we know that there was an issue for this particular URL, which is great. So we've handled a specific exception, and we are only really dealing with this particular exception. Any other exception should get raised. So for example, let's assume we go back and get another glass of water. Our cat walks over our keyboard again. We've introduced something that makes no sense, and we get the name error that we would expect in that case. So this is a little bit more robust than what we had before, which is good. Okay, so that's try and accept for this particular example. Now, another thing that I want to cover here is assertions. Assertions are great for checking assumptions about how your program is running and what objects should be. And so in this case, I'm making a few assumptions in my has reference data function. And one of the most important assumptions is that this input is a URL for a DOI. And so one thing that I could do, if I wanted to, is try to make sure that that is true. And so I can use an assertion to do this. And what it looks like is you use the word assert, and then you make some assertion. So for instance, I think that the input to this, or the beginning of the DOI should start with HTTP. Okay, so I'm looking through all of these publication URLs, and yeah, these all start with HTTP. So let's just assume that I want that to always be the case. I can do this with an assertion. Okay, so I still get false and true when I expect to, but now, if for whatever reason somebody tries to use this function and they pass in something that doesn't start with HTTP, like cookies, nom nom nom, I get an assertion error. And you can see in this traceback that it's traced back to this assertion that the DOI has to start with HTTP. And I can make this even a little bit better by adding a message. If the assertion doesn't hold up, this message will get printed and can give a user a clue. So I could say something like the input DOI needs to start with HTTP. And now, if somebody passes in some input that's not valid, they'll get this message that gives them a hint as to how to make it valid. So if I had HTTP:// cookies nom nom nom, that would satisfy this assertion. Okay, so that's assertions. And next, what I want to do is actually test this function, right? So these two function calls where I kind of expect false and true, in some sense these are tests. If I get some output that's not expected, then I might know something's wrong, but they're not tests that will automatically run for me, right? Like I'm not actually checking to see in the code that this is false and that this is true. So how can we do that? Well, I'm gonna set this up in kind of a minimal Python package to start with. So to make this into a package, we're gonna go and create ourselves a little setup.py file. So this file I want to be called setup.py. Okay, and it's going to be a really simple setup.py file from setup tools, import setup, find packages, and then I'm actually going to call this setup function. Let's call this package site tools, and we'll let Python find where the packages actually live. And in order to give it something defined, let's make a new folder called Site Tools. Go into that folder, and let's actually make some files here in the folder. So the first file we're going to create is going to be called utils.py. And in here, I want to define this function. So first I need to notice that there are a couple of things I need to do here. One is I need to define the CR object, which in our notebook we define it just like this. And so we can use this same code. In order to define this, I need to import habanero. I'm also going to need to import requests, right? Because I'm using this particular HTTP error. And I think that's probably all that I need to import here. I don't have any pandas code running in this function, right? And now the other file that I need to make inside my little site tools package here is going to be an init file. Okay, and in here there's not going to be much. I essentially just want to be able to import my has reference data function. Okay, cool. So there we have our really simple module utils.py and then an init.py file. Now what I can do is actually try to install this little Python package. So let's open up a terminal, and I have a Conda environment that I've been using. I believe it's called sites. Yeah, so let's activate that. Conda activate sites. Great. So to install this package, what I'm going to do is type in pip install -e period. So -e means editable, so I can edit this package as I'm using it. And now I can modify my code. I don't really have to import habanero or requests anymore. Now I can actually just import my little package, site tools. Okay, and actually I'm going to restart this kernel just to be safe. Okay. So I'm importing my new package. I'm still reading in the data as before. Now I don't really need to define that. I don't need to define this function anymore because it's in this site tools package. So I can, for instance, do this site tools.hasReferenceData, and now instead of defining my function in my Jupyter notebook, I am defining my function in my little Python library. And so we can do the same thing throughout our code. And let's just be sure that it's still working as we expect. Great. So the behavior hasn't changed, right? But now I'm defining this logic elsewhere. I'm defining it in this little package. So how do we actually test this? I'm going to show you PyTest is my preferred testing framework. It's really easy to use, which I enjoy. And if you go to docs.pytest.org, the documentation is really good. And so that provides a good starting point. But I'll show you a quick demo. If I want to add some tests to my package, I'm going to make a folder called tests. And then within that tests folder, I'm going to make a new file. And this will be called test utils.py. Okay, so what do I actually want to test here? Well, I know that I need to actually import my function if I want to test it. So somewhere up here I need to have something like from site tools import has reference data. Okay, so now I'll have my my function, I should be able to test it. So one test that I think we could make is essentially to make sure that we get true when we expect to get true. So for instance, for this particular publication URL, if everything's working correctly, we should be able to get true. Okay, so how are we going to write this test? Well, I'll probably need this DOI here. And this is a little bit low tech, but I am going to copy this and I'm going to use that in my test here. So with PyTest, you usually want to start your tests with the word test, and every test is a function, which is kind of nice. So if I want to write test, I'll define a function and I'll call it test has refs. So I want to test something that I know has reference data. And the really nice thing about PyTest is if you know about assertions, then basically you know how to write tests, because all of PyTest is essentially just assertions. So I can say assert has reference data, paste in this DOI. So I expect that this function call has reference data, that DOI, should be true. And if I say assert something that's true, and this runs and returns true, then this test will have passed. So let's see if this test actually passes. This is just my terminal again, and you can see that I am sort of in the top level directory. To run PyTest, you can just type in PyTest, and you can see that the test session started. You get a little bit of information about like what version of Python, PyTest, etc. you're using, and I can see that one test passed in about half of a second, which is great. So I've got a passing test. Cool. All right, let's see if we can add some tests. So let's think a little bit about like what should we actually be testing. Right now I've tested that I get true when I think I should get true, but what have I not tested? Well, I haven't tested, for instance, that this assertion actually does what I want it to. So I haven't written any tests for invalid input. So how would we do that? Well, one thing we could do is write a test invalid input. And if I provide invalid input, I expect to get an assertion error, right? And we can sort of remind ourselves what that looks like. So if I say site tools has reference data and some invalid input, yeah, I get an assertion error. Cool. So let's make sure that we get that assertion error. And we can furthermore make sure that we get an assertion error with this type of message. Okay. So the way that we make sure we get a particular error with PyTest is going to be with syntax something like this: with pytest.raises assertion error, let's try to do something. So let's try has reference data with some invalid input. Okay. So what is this actually doing? So with pytest.raises assertion error is basically a way to say that whatever I'm calling here should raise an assertion error. We can make sure that's true if we run our tests. So same syntax as before, clear this out. To run the tests, you just type in pytest. And now I'm getting an error. PyTest is not defined. Okay, so that's an easy fix. Essentially the problem is I'm using PyTest here, but I haven't actually imported PyTest. So let's fix that. Import PyTest. Now let's see if this test works. PyTest. Cool. Yeah, so 2 tests passed in half of a second. All right, well that's good news. So now we've got a bit of a test suite going here. One last thing to think about is, if I'm rerunning this test suite a whole bunch of times, I don't necessarily really want to hit the Crossref API every single time that I'm running this test. This is particularly important if you have like an intermittent internet connection where maybe you run the test, but your internet is not working well, so you can't reach the API, and then it seems like your package is broken, but really it's just your internet connection. So one thing we can do is use something called a VCR, or a cassette. And so that's a way to record the response from the API so that you can just play back the response when you run the test instead of having to hit the API every single time. So there's a great tool for this called PyTest VCR. And let's just take a quick look here. You can install it using pip install PyTest VCR. And you can see that the way to use it is with this decorator for your functions. So you can say @pytest.mark.vcr, and it'll record the response of that function. So let's go ahead and use this. I'm going to install PyTest VCR. Cool. And now, if I want to actually use this, I should be able to use this function decorator for one of my tests. And this is the test that probably needs it, since this is the only test right now that's actually going to hit the API. This test should exit before any API calls are made, right? Because this is happening on the first line of my function, before we've actually tried to reach the API. So this is the decorator pytest.mark.vcr. And let's investigate the behavior a little bit now that I've got this VCR set up. So I'll run the test suite using PyTest. Cool, they passed. And now if I go into my tests directory, I'll see a new directory called cassettes. And so those, for some of you, this cassettes VCR analogy should make sense. For others, it may be a little bit opaque. But essentially, you can think of the cassettes as recordings of the API's response. So test has refs. Note that this YAML file, which has been generated, has a name that is just like the test that it's associated with. Okay? And so now, if I rerun, note that this took a little over half a second. If I rerun this test suite again, it runs quite a bit faster. It runs in a tenth of a second, and it doesn't need to hit the Crossref API, which is pretty nice, especially as you start to build out larger, more extensive test suites that could potentially be hitting APIs many, many times. Using VCR and cassettes is a good way to avoid intermittency issues and flaky tests. Okay, so let's just do a quick recap with what we did. First thing we did is we wrote a quick little function called hasReferencedData. And what this function does is it takes a DOI as input, and it tries to figure out whether this Crossref API has reference information in it. In other words, can we find out what papers were cited in this DOI? We ran into an HTTP error with one of these DOIs where Crossref just doesn't have a record of this publication. And so we ended up using a try and accept statement to handle this particular error, where instead of actually raising the error, we're going to print the error message and then return none. And then we also decided it might be a good idea to check the input, make sure that it starts with HTTP, and if it doesn't, then we can print out a helpful message to our users to remind them of our assumption about the input. Then we bundled up this function into a tiny little Python library. And to do that, we had to do three things. First, we made a setup.py file. Then we made a directory called site tools. This is just the name of our package. In there, we had some utils module. This is essentially like the logic. This is our helper function, if you will. And then an init file that just allows us to call this function as sitetools.hasReferencedData instead of sitetools.utils.hasReferencedData. And finally, we wrote a test suite using PyTest and went through how to save the output from API calls so that we're not constantly hitting the API every time we want to run these tests. So that's essentially a really quick flyover of try and accept, assertions, and automated testing in Python using PyTest. If you want to dig more into this, I highly recommend looking through the PyTest documentation, which is pretty extensive but also very approachable. And if you also want to dig into some of the test suite for EarthPy, we did use PyTest to generate that test suite. And so you might find some good examples in there that you've seen before. All right, and with that, I will pause this recording. Thanks all. See you later.